We will review DFM Pro functions embedded inside of the NX Checkmate application in this non-parametric machine part. We will use a prismatic mill check to analyze this data. We see there are several errors in our checkmate results. Using the NX see-through all command, we can see clearly the location of internal features within this machine part. The first check identifies deep hole issues, where the ratio of the height versus the diameter of the hole exceeds the standard. In the DFM Pro Rule Manager, we can see these industry standards. Using NX see-through capability, we can quickly visualize one of the features with a deep hole error. If the hole depth is too deep and the diameter is too small, in many cases this will cause the tool to break. Next to the hole, we see the tool accessibility error. We see that there is geometry covering the hole, so there is no way to gain access to drill the hole. Another error DFM Pro has identified is a sharp corner in a pocket of this machine part. In reviewing the DFM Pro help page, manufacturing recommendations are made to avoid the additional cost of using EDM. If it's not so critical to have a sharp internal corner, the design engineer can quickly add a fillet or have a hole drilled first and then mill the pocket to resolve this issue. DFM Pro for sheet metal quickly identified a hole feature that is too small. In standard sheet metal practice, the hole diameter must be at least equal to the thickness of the part. Another common check is the knife edge condition. This is considered to be a safety constraint. This exterior edge could possibly lead to injury or part failure. In the DFM Pro injection molding checks, a thin still condition is noted when two of the plastic walls are too close together, which in turn affects the tooling where the core and the cavity walls are very thin. This ultimately affects the tool life in the plastic injection molded parts. In this assembly check, we will review tool reach and fastener accessibility. The geometry of a component part is going to interfere with the tool which will be used to assemble or disassemble the fastener below. In complex assemblies, identification of such interference areas is very difficult. Let's take a look at a hole alignment rule violation. The holes on these two components are not lined up correctly. Minor misalignment of holes will result in issues related to joining. Fasteners may not fit correctly. Again, this is usually not found until assembly or out on the shop floor. DFM Pro has a variety of out-of-the-box rules, and users can add more company best practice rules into this tool for implementation. Thank you.